All right, now let's look at something that's a little bit interesting when we deal with inequalities, and that is called a compound inequality. Now, I think that the textbook that we're using right now currently calls them three-part inequalities, but that's actually the first time I've heard that. Usually, we just call them compound inequalities. Now, let's think about what this means for just a second. This says negative 1 is less than or equal to x is less than 3. We could think about that in two parts if we wanted to. We could say that negative 1 is smaller than x, which in turn is smaller than 3. Or another way that I like to look at it is x is in the middle of these two numbers. If you look at it like that, it actually makes a whole lot more sense. X is between or in the middle of the negative 1 and the 3. So we're talking about all of those numbers in between negative 1 and 3. Now, another thing that I want you to notice about these before we go any further, you see how these symbols are both variations of less than? One's a less than, one's less than or equal to. But that has to be. In order to deal with a compound inequality, we need to have the less than or the less than equal to. We can't use greater than with them. It's you could, but it's very bad form, so we don't do that. Let's get a graphical picture of what this looks like. If I were going to look at all of the x's that are in between negative 1 and 3, wouldn't that look like this? I'm going to kind of make squiggly lines or shade everything in between the negative 1 and the 3. Now, what we have to do, though, to finish out is we have to talk about our endpoints, because we have to have brackets or parentheses to tell us, are they included or are they not included? To do this, we have to look at each endpoint individually. So looking at the left endpoint here, the left side of this graph, that says negative 1 is less than or equal to x. Well, because of that equality there, that tells us that the negative 1 is included, so we have to use a bracket. For the right-hand side, x is less than 3. That doesn't have any equals in there anywhere. So that is a parenthesis because there is not equality in there. So this is what this looks like. Let's work a problem and see how it's going to look when we have to actually solve to find it. Here we have one that says 4 is less than 3x minus 5, which is less than or equal to 10. Now, do we notice here that in a way it's almost as if you have three sides, sort of, instead of, with an equation, if we just had 3x minus 5 equals 10, we just have two sides, one on either side of the symbol there. But in this case, it's like we have three sides. We have a left, a middle, and a right. Well, just like in solving equations and in solving inequalities, you can do anything you want to as long as you do it to both sides so that we maintain that balance. That applies even to a compound inequality. As long as I do, whatever I want to, adding, subtracting, multiplying, dividing, as long as I do it to all three pieces, then I've still maintained that balance and we've not lost anything. So in order to get x alone here in the middle, the way that it was in my initial example here, the first thing that I need to do is I need to get rid of the 5 that's attached to it. So we're going to do the opposite of minus 5, which would be plus 5, because minus 5 plus 5 cancels out. Now, we are allowed to do that as long as we do it to all three sides, sort of. You think about it that way. That way we've maintained balance. So now, on the very left, we have 4 plus 5, which is 9, less than 3x in the middle, less than or equal to 15.